In one of the coldest, most remote places on Earth, there's a waterfall that looks like it's bleeding. It flows out from beneath a glacier in Antarctica, staining the surrounding ice a deep, unmistakable red. For over a century after it was first discovered, scientists didn't fully understand what was causing the color, or how liquid water was even flowing there in the first place. Blood Falls sits at the edge of the Taylor Glacier, in one of Antarctica's McMurdo dry valleys, a region so cold and dry it's considered one of the closest environments on Earth to conditions on Mars, which is part of why NASA has used it as a testing ground for research related to extraterrestrial life. It was first documented in 1911 by geologist Thomas Griffith Taylor, the explorer the glacier is now named after. When Taylor and his team came across it, the immediate assumption was that the red color came from algae, similar to how certain algae blooms can turn bodies of water red or green elsewhere in the world. That explanation didn't hold up. Later research revealed the real cause was something much stranger: iron. Trapped beneath the glacier is a pocket of extremely salty water, sealed off from the surface for what scientists estimate could be over 1 million years. This water is rich in dissolved iron, and it's kept from freezing solid, even in Antarctic conditions, because of its extremely high salt content, which lowers its freezing point significantly below that of regular water. When this iron-rich water eventually finds a crack or fissure and reaches the surface, it comes into contact with oxygen in the air for the first time in possibly over 1 million years. That oxygen causes the iron to rust almost instantly, the same chemical reaction that turns metal reddish-brown, which is what gives Blood Falls its dramatic, blood-red color as it flows across the ice. But the color turned out to be the less remarkable discovery. In the 2000s, researchers studying the trapped water beneath the glacier found something that genuinely surprised the scientific community: an entire ecosystem of microbial life living in that sealed-off pocket of water, isolated from sunlight, oxygen, and the outside world for possibly over 1 million years. These microbes have adapted to survive by metabolizing sulfate and iron compounds instead of relying on photosynthesis or oxygen the way most life on the surface does. It's one of the most extreme examples of life found thriving in complete isolation, in conditions that would be lethal to almost every other known organism. This discovery has become genuinely significant beyond just Antarctica. Because the environment beneath Taylor Glacier is considered a reasonable approximation of the kind of subsurface, ice-covered water systems believed to exist on Mars and on icy moons like Europa and Enceladus, scientists studying Blood Falls have used it as a model for what kind of life could theoretically survive in similarly sealed, sunless environments elsewhere in the solar system. If microbial life can survive over 1 million years cut off from sunlight and oxygen beneath Antarctic ice, that meaningfully raises the possibility that comparable conditions elsewhere in space could support life as well. More than a century after it was first discovered, Blood Falls isn't a mystery in the sense of being unexplained anymore. Scientists understand the chemistry behind the color, and much of the biology living beneath it. But it remains one of the strangest reminders on Earth that life can persist in places that seem, by every reasonable measure, completely inhospitable. And in a sealed, sunless pocket of water beneath the ice, it's been doing exactly that for over 1 million years.